Welcome back. This is the final lesson on the topic of hardware, and in this lesson I'd like to briefly review some of the questions that you might be asked on the topic of storage and how you might start to formulate answers to these questions. The four question areas that I would like to address are the comparison of different storage media, the so-called quality trade-off and its implications, how we could use cloud storage to solve storage problems, and issues around backups and file security. I want to very briefly mention what to do if a question comes up where you're asked to compare storage media. The three types of storage media you might consider are magnetic, optical and flash. You should have a brief idea of how these storage options work and what their advantages and disadvantages are. If you can't remember this, go back to the previous lesson where I review this in more depth. The next area of questioning is what I call the quality trade-off. This is an issue that applies to multimedia files of a range of different types. I'd like to talk briefly about what makes a file higher or lower quality and how quality is achieved, and think about what problems may occur. I'll concentrate mainly on images because that's quite easy to visualize, but it applies to all forms of multimedia, including sound and video. The first thing to be aware of is how images are stored. Images are stored inside the computer as files which record the colour of pixels. Pixels are points of light which make up an image. They're the smallest possible part of an image, and when you print an image the pixels are rendered as ink. The colour of each pixel is stored as a code number. So just like any other file, an image file is a series of binary code numbers, each code number standing for a colour. The image file size will depend obviously on the size of the image. The number of pixels will depend on the number of what we call dots per inch. We mainly talk about inches in this context rather than centimetres because most of the work in this area was originated in the United States where they use feet and inches. So the number of pixels, the number of dots in the image, depends on the overall size of the image and the number of dots in a square inch. And the number of bits, the size of the image file, depends on the number of pixels multiplied by the number of bits that are used to store each pixel. So you can see that there are a number of variables there that determine how big the file size is going to be. The amount of storage is therefore dependent on obviously the width and breadth of the image, but within a given size of image it depends on the number of pixels used in a given area, so how tightly packed, how small or large the pixels are, and also the number of codes used to store the colours, and this is called the colour depth. So you can see some images here which are stored using very large pixels, and that makes the image blurry, but it means there's less for the computer to store. So that gives us a very clear quality trade-off. A higher quality image requires a larger file size. That's because it's got more pixels and the pixels are using larger code numbers to store the colours. These high quality images will be larger file sizes. That means they'll use up more storage, but more importantly perhaps nowadays they are slower to download over an internet connection. You can visually very easily see the difference between a higher and lower quality image. I've got an example here, and the top image is lower quality, so you can see there's less gradation in colour and there's less detail in the fine parts of the image. Some people deliberately will choose the higher quality, and some might prefer the visual effects of the lower quality image. In any case, it's directly related to the way that the image is stored. We can sometimes get away with high quality and a low file size by using a technique called compression, which sometimes can be achieved without loss of image quality. But that's an entire topic, and we'll deal with that next term. I also want to talk about cloud storage, which is storage that is accessed through an internet link. So when we talk about cloud storage, we're not talking about a particular method of storage, such as magnetic or flash storage. What we're talking about is accessing any storage through an internet link. And typically we'll use storage space on the remote server of a large hosting company, such as Dropbox or Google Docs. Cloud storage has many advantages over other forms of storage. If you've stored your work on a cloud storage option, you don't have to carry your work around with you, but wherever you sit down at any computer, you can access your file by logging on. As I say, logging on to Dropbox or OneDrive is what we use at the college. There are some disadvantages. If you can't get an internet connection for some reason, you can't access your data. And so some people like to take a flash drive backup of their work. And some people have concerns about the privacy or security of the data. For example, if one of the large tech companies was hacked or went bust. It hasn't really happened yet, but people do have those concerns. And finally, I'd like to talk briefly about the topic of backups. The good general rule, either as an exam question or actually in real life practice, is to always make sure you make frequent backups. Of course, taking a backup takes a little amount of time, but you've got to trade off that time against the risk of losing important data. When you go to make a backup, the important thing is to choose an inexpensive but high capacity storage medium, because you're going to basically double up all your storage requirements. Backups don't usually need to be accessed except in an emergency, so it's okay to choose a slower storage option, and some places still use magnetic tape because it's got very high capacity and isn't very expensive, and they can back up their entire company or organisation's files overnight onto tape, hopefully never have to even touch it again. An associated topic is what we call RAID. That's a redundant array of inexpensive disks. And this is another way of doubling our storage. What happens is, as our files are saved, they're dual saved onto a bank of RAID disks. And that means we've got a constant backup of every item of data in case any of our main files get lost or corrupted. And this is a very high security way of ensuring that every single piece of data in your company is kept safe. So to recap, you should be able to compare different storage options for different purposes and be aware of this quality trade-off that brings us high quality images, sound, video as a trade-off for high file size. You should know what cloud storage is and why we might choose it, and the importance of taking backups. We haven't done any programming for a bit, so I'd like to leave you with a couple of programming challenges. Write a Python program to calculate the size of an image file with the inputs that I've just been talking to you about earlier. And if you've got time, investigate another large topic which I haven't really got time to go into now, about how sound files are stored. What are the factors that determine the size of a sound file, as well as the number of seconds of sounds that it contains, and create a program to calculate file size from these inputs. Okay, so I thought you might like a little bit of programming to do for a change, and this is the end of the hardware topic. Next session we're going to talk about the way that the processor works, looking in more detail at the use of registers and the fetch execute cycle. Okay, so bye for now.